Hi everyone! In today's video I will be going over the Unit 5 test review, Unit 5A test review. Alright, the first three here are graphs, and the question is, determine if the following are functions or not. So the answer is going to be a yes or a no. Remember, on a graph is a function if it passes the vertical line test. So quite literally, if I draw vertical lines, like these grid lines here, through my graph, it can only hit the graph one time. As you can clearly see on A here, this very much fails the vertical line test. I could pick so many examples. If I looked at this vertical line here, it passes through twice. So, this one is a no. B, vertical line test. If you look as I go through here, it's going to keep hitting the graph one time. Some of you might have a few questions here. This will not straighten out to vertical. It'll keep going. It's very steep. So, yeah, this passes the vertical line test. No problem. C. Now, there are some areas of this graph that do pass, like down here on the left, that passes the vertical line test. But if I go over here, here's a spot that passes not only twice, but 3 times. So, obviously, that's a no. And it doesn't matter how many times it fails. If it fails once, it's out. It's done. It doesn't work. D and E are sets of points. We don't have a graph here, so what we're looking for is we're looking to see if any of the X values repeat. Only the X values. The Y values can repeat, that's allowed. The X's cannot. So just look at the X values and see if you have the same number twice. And we do. The first and last point both have a 2. So no. E, we have a 1, 2, 3, and a 4. No repeated values. So that one's good. Next section. Given f of x equals 3x plus 1 and g of x equals 2x minus 3, find the following functions. A lot of students are getting tripped up on these. These are just your basic operations. Adding, subtracting, multiplying, and dividing your given equations or your given expressions. We're not plugging one expression into the other like a FOG or a GOF function. I'll skip ahead and show you one of those just to give you an idea of what you would see for that. We don't get to that until page 3, where we start seeing, like this one is M of Q. We're plugging a function into another function. And then down here specifically are FOG and GOF. So, we're not doing any of that yet. So just pay attention to what the symbol is. This is a plus. So we're just going to add F and G. You can write out all of this fancy notation if you want. You don't have to. If you just want to write out what you need to write out to get your answer, that's fine. So F is 3x plus 1. Plus G is 2x minus 3. So F is the pink there. And then G is the purple, just to give a little bit of a visual. Okay, so all we can do here is combine like terms. 3x and 2x are like terms. That will give us 5x. 1 and negative 3 are like terms. 1 minus 3 is negative 2. I can't do anything else, so I'm done here. F minus G. You want to be careful with subtraction. A lot of students mess up subtraction, and I'll explain why. We go ahead and write this out. F minus G of x Since we're doing subtraction, I'm going to be a little extra cautious and use parentheses when I first plug in. And I could have done that with the addition, but they're not necessary when you're adding things together. But subtracting, absolutely. So, 3x plus 1. And I don't need to put the first one in parentheses, but I'm going to just to be consistent. Minus, you have to put the next set in parentheses. 2x minus 3. If you forget these parentheses, this is where we're going to see mistakes. Alright, this next line, I can drop the parentheses from the first expression. Since it comes first, there's nothing I have to worry about. Here's the problem. When you're subtracting, you're not just subtracting the 2x, you're subtracting all of this. So what I'm saying, when you have a negative in front of a set of parentheses like this, you're going to treat it like it's a negative 1 in front, and you want to distribute that negative inside of the parentheses. When I do that, it's going to change both of these signs. So now I'll have minus 2x, and then a negative 1 times negative 3 gives us a positive 3. From here, I can just treat it like any other expression and just combine like terms. So I have 3x minus 2x, that's x, 1x, just x. 1 and 3, that's 4. If you're still confused, here's another way to explain why we have to do this step. A lot of students, if they don't do the parentheses, then they just do minus 2x minus 3. That's not the same thing as what I just did here. Also think about it. If I were to just go back and forth and subtract, if I did it in my head, I would be thinking, okay, 3x minus 2x is x. 1 minus negative 3, think about it, 1 minus negative 3, that becomes 1 plus 3, that's a 4. So, you can think about it that way too, but on paper, this is what this looks like. You really do need to know how to do this because this is going to keep coming up. It is a very small but easily made mistake, made all the time in Algebra 2. And then if you plan to go to pre-cal, definitely something to be aware of. Alright, multiplication. F times g of x. So multiplication, I am definitely going to use parentheses here, and I'm just going to write them next to each other. 3x plus 1 times 2x minus 3. Again, this is my f of x. This is my g of x. We're just multiplying here. So you can use the FOIL method. First, outside, inside, last. I also just call it double distribution, where you distribute the first set of parentheses. So I distribute the 3x first. So I have 3x times 2x, that's 6x squared. 3x times negative 3, that's negative 9x. And then I distribute the 1. So since I'm multiplying by 1, it's just going to be this. Plus 2x minus 3. And then if you do it in this order, your middle terms, you can combine them. 6x squared, negative 9x plus 2x. Negative 9 plus 2 is negative 7x minus 3. And that is all I can do. So I'm done. Alright, some more of this stuff, but now we're plugging in numbers. So I'm going to be doing 2 separate calculations, and then I'll put them together at the end. So, number 5, and we're going to be using these 2 new functions here. Make sure you're looking at the correct ones as you're doing the problem. Might have to retire this purple in a minute. I have found a replacement. Let's use this one. Okay. So we're going to do f of 2 first. Remember, this means that's what your x value is when you see this number inside. So this means that x is 2. Make sure you're looking at the correct function. We're looking at the f function, so I'm going to look at the pink one. We're going to plug a 2 in for this x, so we'll have 2 squared. And then just so I don't forget, I'll go ahead and set up the g function as well over here. So I need to find f of 2 and g of 5. So over here, I'll do g of 5. So again, you're going to plug 5 into the g function. So 5 goes in for x, so we have 5 plus 4. Then I'm going to find both of these. F of 2 equals 2 squared is 4. G of 5 equals 5 plus 4 is 9. And then you go back up here. They're asking me to subtract these. F of 2 minus G of 5. So to put this all together, I'm going to have 4 minus 9. And that is going to give me negative 5. Number 6, f of 3 minus 7. So this one's a little easier, less work. Find f of 3 and then subtract 7 from it. So, f of 3, again, we are using the pink function here. Make sure you put it in the correct one. So 3 is going to go in for x. We have 3 squared. F of 3 equals 9. Now make sure you pay attention. A lot of us would be tempted to stop here. We're not done. The question is f of 3 minus 7. So now we know f of 3 is 9. So f of 3 minus 7 is just 9 minus 7, which is 2. Now I'm done. Always make sure that you check and that you answered the question fully when we have multiple steps here. It's very easy to do 1 step or 2 steps and think we're done when you're actually not. Alright, next one, g of 7 times f of negative 3. Again, we'll find these separately and then we'll put them back together. G of 7 equals, make sure you plug it in the right one. G is the x plus 4. So 7 plus 4. So g of 7 was the block function. G of 7 equals 11. So there's half of what I need. And then f of negative 3. F is this pink function over here. It's x squared. So negative 3 squared. F of negative 3 squared is a positive 9. And then coming back to the original problem, they want us to multiply these answers. So, g of 7 times f of negative 3 is 11 times 9, which is 99. So just taking it apart, putting it back together. Page 2. Given the tables shown below, express the following. So now we're doing the same stuff that we just did, but we don't have equations, we just have a table. So this is just about whether or not you can read a table. So on the left side you have the f function, and then on the right side you have the g function. Just make sure you are paying very close attention here as you're looking back and forth, because there's not much work to be done here. A lot of this is going to be you looking for the answer. F plus g of 6. This means x is 6 here. We don't have an equation, so we can't figure out f plus g first. We have to do f of 6 plus g of 6 and then add them together, which is a very convenient thing we can do here. So f of 6 plus g of 6. You're going to let them both have that 6. Find out both of these, add your result. All right, you want to be extra careful here. This means, again, that x is 6. So, our question here, and for clarity, I'll write this out one time. I'll do a little bit of, I guess, notes up here for those of you who need it. So, reminder, x is 6. So, we need to go, we're looking at the f function, so we need this table. If x is 6, the question here, what is y? So 6y, your f of x, is 30. So f of 6 is 30. And then same question here for the g function. If x is 6, what is y for g? So let's go to our table for g. X is 6, y is negative 14. So we have our numbers, now we just need to add them together. 30 plus negative 14 is positive 16. All right, B, f minus g of 8. So we're going to give 8 to both of these. F of 8 minus g of 8. We'll figure out what each of these are when I plug in the 8 and then subtract the two numbers I get. So, f function, when x is 8, f is 26, minus g function, when x is 8, y is negative 22. All right, 26 minus negative 22. When we have two negatives in a row, remember they make a plus. So 26 plus 22, that's 48. F times g of 2, so give the 2 to both of them. F of 2 times g of 2. F function first, when x is 2, f is 23. Times g of 2, when x is 2, g is 28. Oof. This one you will definitely want a calculator to do. I couldn't even do this in my head. 23 times 28 will give you 644. Last one, f over g. Remember, this is division, if you don't recognize it. A fraction is division. F divided by g of 4. So, give the 4 to both of them. So I have f of 4 over g of 4. All right, f function, when x is 4, f is 16. When x is 4, g function, g is 32. You could put these in a calculator and divide them. That's perfectly fine. If you want to keep it as a fraction, please reduce it as much as possible. Hopefully you recognize that 16 is half of 32, so this would be 1/2 if you leave it as a fraction. Or if you just put it in a calculator and divide, you'll get 0.5. So either one is fine. Number 9, we're doing the same thing as number 8, but we're reading a graph now instead of tables. This one you'll want to be a little more careful. Given the graph shown below on the interval -4 to 4, with line segments connecting certain designated points whose x and y values are integers, express the following. Okay, A, f plus g of -2. So, give -2 to both f and g. F of -2 plus g of -2. We'll figure out what both of these are, and then we'll add them together. So, this is your f, this is your g. Again, make sure you are looking at the correct graph. It's very easy to look at the wrong graph and get the wrong number. All right. Remember, this is going to be super important when you're reading a graph. That's your x value. So, f graph from here. When x is -2, so go to -2 on the x-axis. You're going to sweep up and down until you find a point. Our point is here at 1. So when x is -2, the y value is 1. And then we'll do the same thing on the g graph. Again, -2. and then you look for a point. The point here is at 1. 1 plus 1 is 2. Again, f minus g of 4, give 4 to both f and g. F graph, f of 4 when x is 4, so we're here on the x-axis. Sweep up and down, find a point. My point is down here when y is negative 3. So when x is 4, y is negative 3. Negative 3 minus, same thing, g graph, we're still looking at 4 as our x value. Sweep up and down, find your point. Here, our y value is actually at 4. So we have negative 3 minus 4. That will give us negative 7. C, f times g of negative 4. Again, give negative 4 to both f and g. So we'll find f of negative 4 times g of negative 4. So f of negative 4, I'm going to come back to the f graph. X is negative 4, so we'll go to negative 4 on the x-axis. Sweep up and down till you find your point. Our point is here at positive 3. So f of negative 4 is positive 3 times g graph, g of negative 4. Negative 4 on the x-axis. My point is down here, also at negative 4. 3 times negative 4 gives you negative 12. All right, last one, f over g, division. Again, you can write it as a fraction and then go from there, so I like to do. So give 2 to the f and the g. So we have f of 2 over g of 2. Remember, our x value here is 2. So go to 2, we're starting on the f graph, 2 on the f graph. And our point is actually already sitting there, so our y value here is actually 0. Same thing, g of 2, g graph, 2, sweep up and down, my point is here at negative 3. Good news, if you didn't already know this, if you put it in your calculator, you will see very quickly. If you have 0 on top of a fraction, your answer is going to be 0. Here we have this exact same concept, but in a slightly more difficult graph. From the graphs of f and g in the figure, find, same idea, 10. F of 3 minus 2 times g of 8. Don't get tripped up here. Just go with it. So, we're going to first find f of 3. Reminder, x is 3. And if it helps, you can highlight the graph in a color of your choice, just to make sure you're looking at the right curve at all times. So, I'm going to look at the pink for the f. And then g, since I'm using black, I'm just going to make it darker. G of 8. Okay. So first for f, on the pink line, when x is 3, what is y? So make sure you look carefully here, because the only notch that's marked is 2. So 3 is right here, and then you go up until you hit the graph. So I hit f right here. You can even put a point there if you like, which is 2 for the y value. So for the f graph, when x is 3, y is 2. 2. Minus, I'm going to bring down this 2. Reminder, this is multiplication, so I'm going to put parentheses. And then when I get g of 8, that's going to go in here. Alright, same thing. Different x this time. This time x is 8. So I'm looking on the g graph. We want x where x is 8. So we got 2, 3, 4, 5, 6, 7, 8 is all the way out here. This is 8. Go back up. Now this time I'm looking at g, so I'm going all the way up to the black curve, not the pink one. So we got 1, 2, 3, 4. That is our y value. When x is 8, g is 4 on the y-axis. Now I'm just going to quickly do this math. Remember your order of operations, I have to multiply these first. 2 minus 2 times 4 is 8. Then 2 minus 8 is negative 6. One more. F of 2 times 2g of 8. Now notice this is the same as it was over here. So if you notice that, you can save yourself a little bit of work. I already know 2 times g of 8. So let me do my underlining over here. This is 2 times g of 8, turned out to be 4. So I'm going to save myself a little bit of time by noticing this is the same. Times, and then when I find f of 2, I'll put it right here. So this time, for the f graph, the pink curve, x is 2. So I need to figure out where it hits the pink curve. So go up, hits right there at 3. So f of 2 is 3. Now, this is all multiplication, so you can multiply this in any order you'd like. I'll go ahead and do 2 times 4. 3 times 8, which gives me 24. Halfway done. Next page. Hopefully up to this point that felt pretty straightforward. This is where it's going to get just, I'd say, a tad trickier, but even the top, like 2/3 of this page isn't that bad. For the functions, m of x equals the square root of 6x plus 3, and q of x equals x plus 5, calculate the following. M of q of x for number 12. I'm going to find a different color other than black. Use this blue here. So M I'm going to let be pink. And Q will be blue. Again, you can write out as little or as much of this like notation stuff as you like. What matters is that you get to the correct answer. So if you don't need to write down exactly everything I'm writing, that's fine. Write down what you need to write down. So M of Q of X. Actually, what I like to do is start with the outside function. So this is the main. So M is main, since it's on the outside. So I'll start with m of x by itself, which is the square root of 6x plus 3. So I'm taking this main function and I'm plugging q into the function itself, so inside for this x. So when I write it over here, so my colors will come in, m of q of x, my blue function, equals square root. I'm going to write out m until I get to the x. 6, and then in parentheses, I'm going to replace that x with all of this. So this was x plus 5. And then I'll finish it off from there. Plus 3, carry over the square root. Now, as you can see, I'm not going to get a full number here, so I'm just going to simplify it as much as possible. Square root. I can distribute the 6 inside of here, so I'll do that. 6 times x is 6x. 6 times 5 is 30. Bring down the plus 3. We're not multiplying 6 by 3. There's only one more step here. I can combine 30 and 3 to get 33. So the square root of 6x plus 33 is my answer. Alright. I actually like these next two a little bit better because we're working with actual numbers. Q of m of 1. So let's kind of unpack this here. Let's figure out what m of 1 is, and then we're going to plug that into Q. So we're going to take this one step at a time. So I'm going to start there. So m of 1. So we're going to take our m function, which is this here. And remember, we're just replacing x with 1. So we'll have square root of 6, and then instead of x, we'll have 1. 6 times 1 plus 3. 6 times 1, that's easy, that's 6. Plus 3 is 9. Hopefully you all recognize that the square root of 9 is 3. So we know m of 1 is 3. We're not done yet. Now I'm going to take my starting problem. I don't know why every time I write a Q, it turns into a G. So the question was Q of m of 1. Now I know that m of 1 is 3, so I'm going to replace that with a 3. So I'm plopping that, or dropping that right in here. So now it's Q of 3. So remember, now I'm looking at my blue function, Q. So I'm going to put 3 in for x. 3 plus 5, which is 8. I have now fully answered the question here. So 8 is my final answer. Let's do that one more time. This time we are starting with Q. We're going to find the Q of 8 and then we'll put that into M. So this time I'm starting with the blue function. So we have Q of, oh my goodness, Q of 8. And then our function is x plus 5, so we're going to put 8 in for x. So 8 plus 5. 8 plus 5 is 13. So now we know the blue part here is 13. So now I'm going to bring this down. So instead of Q of 8, I actually know my number is 13. So now I'm going to use my pink function, m, plug in 13 for x. So I have square root of 6, here comes the x, which is 13, plus 3, carry over the square root. 6 times 13, that is 78, plus 3. That's going to give us the square root of 81. Hopefully you recognize that that is 9. I have fully answered the question here, so I am done. 2 more sections on this page. More of what I just did. We now have 3 functions in the directions instead of 2. So again, make sure you are closely paying attention to which function they are asking you to look at. So you don't have to use the colors if you don't want to, but I know some students really enjoy color coding. It helps. So just make sure you are paying very close attention on these problems specifically. Otherwise, we're just doing the same thing that I just did above. G of h of negative 2. So we're going to figure out h of negative 2. Then we'll replace this and plug whatever that number is into g. So here I've got my orange function, h of negative 2. H of negative 2. So I'm looking at h. H is x minus 3. So I'm going to put a negative 2 instead of x. Negative 2 minus 3 is negative 5. So now I can replace h of negative 2 with this negative 5. I'll bring down my original problem and replace. Now this is negative 5. So now I'm using g, which is the blue function here. So now I'm replacing, we have 5x, I'm going to replace x with negative 5. 5 times negative 5 will give us negative 25. Done. Number 16, h of f of 4, starting with f, which is my pink function. F of 4 equals, my function is 2x squared. I'll replace the x here with a 4. 2 times 4 squared. And then remember your order of operations. I can see some students making some mistakes here. We remember the order of operations is PEMDAS. Please excuse my dear Aunt Sally. Why this is important, I can see plenty of students doing 2 times 4, which is 8, and then 8 squared is 64. That is not correct. Remember, P is for parentheses. Doesn't really apply to these parentheses because you just have a singular number in it. The next one is exponents, then you multiply. So you have to do the exponent first. So make sure you do 4 squared before you multiply by 2. So 2 times 4 squared is 16. 2 times 16 is 32. Notice how that is not 64, which is what I said the first time if you did it incorrectly. It will throw off your entire answer. Reminder, you can always type this into a calculator. Make sure you use all the symbols that are written here in your calculator to make sure it's correct. Okay, so inside the parentheses, we now have 32. So I'm going to drop down my original problem, h, and then instead of f of 4, I will drop that 32 in there, h of 32. So now I am looking at orange, since that's h. So I'm going to replace the x here with 32, so I'll have 32 minus 3, which gives us 29. One more. F of h of negative 9. So again, working with h here, which is the orange function. H of negative 9 equals x minus 3. I will replace x with negative 9. Negative 9 minus 3. Negative 9 minus 3 is negative 12. So h is negative 12. Bring down the original problem and replace f, and then instead of h of negative 9, we now have negative 12. And then f is pink. So I'll look at my pink function when I'm plugging in negative 12. 2 times, this is 2x squared, negative 12 squared. Remember, order of operations tells us that we have to do the exponent before we multiply by 2. Negative 12 squared, that's going to be a positive, and then 12 squared is 144. 2 times 144 is 288. And now I'm done. One more section. For the functions, f of x equals 1/3 x plus 5 and g of x equals negative 6x plus 9, calculate the following. F of g of x, g of f of x. These are the Fogg and Goff functions that we talked about at the beginning of 5.2. So this is the format I prefer to have them written in, the way they were given, because I think visually it makes more sense what we're about to do. But just to jog your memory, this is Fogg, this is Goff. So, when we start this, 18, the first function, the one you start with, this is the main function, the outside function. So I'm going to start with the f of x. I'll just write that down. F of x equals 1/3 x plus 5. And then what I'm doing is I'm plugging the g of x function into this x. That's where the color is going to come in. F of g of x equals, I'm going to follow this till I get to the x, 1/3, and then x will be replaced by the g function, which is negative 6x plus 9, and then I'll continue, plus 5. Now don't overcomplicate this fraction here. If you want to talk about in terms of fractions, if I put the -6/1 and I multiply straight across. Sorry, let me back up a bit. If you can't already tell, I'm going to distribute here first because all I have to do is simplify. So when you're distributing, if you want to talk about multiplying fractions, multiply straight across, you'll get -6/3x. So if you notice, all I'm doing is I'm taking the number in parentheses and I'm dividing it by 3. So you can think of it that way. So this will be plus 9/3. 9 divided by 3. Bring down the plus 5. These are going to divide very nicely. -6/3 is just a -2x. Plus 9/3 is just 3, plus 5. Last thing I can do here is combine like terms. -2x plus 3 plus 5 is 8. And I am done. Now let's do the opposite direction. Start with g and plug in f. So again, g is on the outside. It's the starting function, so it's the main function. So first I'll just write down g of x, which is -6x plus 9. And then remember what I'm doing next, I'm plugging all of f into g. So g of f of x, my pink function, equals, and then follow g till you get to this x, -6. Now I'm going to switch over and replace this with the f of x function, 1/3 x plus 5. And then I continue, plus 9. Okay, first things first, I'll distribute this -6 in here. Again, -6 times 1/3, that's like dividing -6 by 3. So -6/3 x. -6 times 5 is -30. Don't forget to fully distribute. And then bring down the plus 9, it's by itself. -6/3, that's -2x. Bring down the rest, -30 plus 9. Combine like terms here. -2x. -30 plus 9 is -21. All right. Back page, only 4 problems, and then we will be done. Finding inverses. So this is a lot of algebra. So 20, I'll write out the 4 steps that I use in this problem, and then I won't repeat it again after that. So step 1, if you remember, is I don't want to work with this g of x, whatever letter it is. I don't want to work with that. I want to work with y. You will replace the g of x with a y. And then bring down the rest. -4x plus 1. So step 1 is rewrite as y. And I'm leaving this very general here because I have a g of x here, f of x here, h of x here. So it just depends on what your starting letter is. Okay, that was step 1. Step 2, this is the inverse step. Remember, when you're finding an inverse, all you're doing is switching x and y. So we are now going to have x equals -4y plus 1. Did a little flip-flop there. Flip x and y. Step 3, solve for y. So basically when we started we had y by itself. We flipped these. Now we want y by itself again. So we have to solve for it. So just bringing down step 2 and I'll solve from there. 2 steps. Subtract 1 on both sides. X minus 1. Remember, you cannot actually subtract these. These are not like terms. This has an x, this does not. So it's x minus 1. Ones cancel. Bring down negative 4y. Last step, we need to get y by itself. We'll divide by negative 4. And then this gives us x minus 1 over negative 4 equals y. I'm going to flip-flop these so that y is on the left. Y equals x minus 1 over negative 4. Alright, last very important step, step 4. Look back at the top. Remember, we started with g, not y. So we need to end with g. So I'm going to put replace y. Again, I'm going to leave this general because the letter is going to change for each problem. So we want to replace y with whatever letter we started with. We started with g. Now remember, this is now the inverse of g. That's what we found. So we need to use that negative 1 in the notation of x equals, and then just whatever you got. X minus 1 over negative 4. You can break this function down further if you want, this fraction down, or you can leave it. They are both correct. And just want to point out real quick, those of you are like, well, if I started with g, so let's put a g back and just put g of x. These are not the same function. This is g, this is the inverse of g. That's why we have to put the negative 1. That's why we did all of this, was to find the inverse. Alright, the next 3, I'm going to follow these 4 steps, but I will not write out the actual steps like I did here. I'll still number them though. So I'm going to need a little more space here, so I'm going to start a little more inward. First step, replace, this time we have an f of x with y equals, bring the rest down, 3x minus 21 over 5. Step 2, we need to do the switch, do the inverse step. X equals 3y minus 21 over 5. Step 3, we start solving. X equals 3y minus 21 over 5. A lot of you get tripped up when you have a fraction from the get-go. Don't overthink this. Think about this fraction as dividing the right side by 5. If we're dividing by 5, what do we need to do to get rid of it, to move it to the other side? What's the opposite of dividing by 5? Multiplying by 5. So multiply by 5 on both sides. So those 5s will cancel. On the right side, we will just have 3y minus 21. And then x times 5, that's just 5x. So here's where I'm at now. Reminder, the goal is to get y by itself. So I need to move the 21. I'll add that over since it's negative here. Cancels. We're left with 3y. Remember, you can't add these, so it's just 5x plus 21. Last step to get y by itself, divide by 3. I'm going to go ahead and flip-flop these for the next step. Y equals on the left, this on the right. 5x plus 21 over 3. Again, just leave it as a big fraction or split it up, it's up to you. Last important step, we did not start with y, we started with f. So instead of y equals, we're going to have f, and then remember, this is the inverse that we have found. So we have to have the negative 1. Inverse of f of x equals, sorry, this is step 4, 5x plus 21 over 3. And this is my final answer. All right, number 22. H of x equals just 3x squared minus 6. Same process. Replace h of x with just a y equals 3x squared minus 6. Do a flip-flop for the second step. X equals 3y squared minus 6. Solve for y. First step, I'm going to move the -6 by adding it to both sides. X plus 6 equals 3y squared. Next, I will divide off that 3. 3's cancel. I'm left with y squared. Bring down x plus 6 over 3. We are almost done. Y squared. We just want y. Remember, the way to get rid of or undo a square is by square rooting. So I'll square root both sides. Now over here, be careful. You are square rooting this entire fraction. All of this gets a square root. It's okay to have this. I know it looks complicated, but we're not changing it. We're not breaking it down. It's going to stay like this, so don't worry about that. So we have y on the right because the square and square root cancel each other out. So the square root's gone. Now remember, when you square root both sides of an equation, the side that keeps the square root also gets a plus or minus sign in front of it. This creates two answers. This was really important back in Unit 4. So now I have plus or minus square root of x plus 6 over 3 as my full inverse equation. Last step, step 4. Hang on a second. Let me take one more step over here. I'm going to switch these first. Y equals plus or minus square root x plus 6 over 3. Okay. From here, step 4. So remember, replace the y with the letter you started with. We started actually with an h. And remember, this is the inverse of h. And then your equation. Plus or minus square root x plus 6 over 3. This is my final answer. Last problem. F of x equals the square root of x plus 5. First step, replace the f of x with y equals the square root of x plus 5. Be careful here. Notice that only x is under the square root, so don't extend it over the entire thing. That will change your answer. Step 2, the inverse step, flip-flop, x and y. X equals the square root of y plus 5. Step 3, solve for y. Again. 2 steps. We have a positive 5, so we'll move it over by subtracting it. Cancels. X minus 5, you can't subtract those. This does not have an x, so bring it down. Bring down the square root of y. Now, we haven't done a ton of these, but don't get discouraged. Don't get too overwhelmed by this. This is basically the opposite of what I just did over here. So over here, I started with y squared, and then to get rid of it, I square rooted it. This time, I'm starting with the square root. And remember, these are still opposites. Square rooting is the opposite of squaring, and vice versa. So if I start with the square root, then my answer to that would be to square both sides. Now, be very careful here when you do it on the left. You are squaring all of this. Next step. Remember, I did this to cancel out the square root. So square root cancels with the square. It's gone. So I am left with just y. Bring all of this down. X minus 5 squared. I'm going to flip the sides here. Y equals x minus 5 squared. You could separate and multiply this out if you want, but again, just leave it. There's no harm in doing that. Last step, step number 4. Reminder, we did not start with y, we started with f. And this is now the inverse of f. That's what we have found. So replace y with f inverse with that -1 equals, and then your equation, your expression I should say, x minus 5 squared. That is my answer. right, that is all for this study guide. I hope that this video helps and explains things a bit more. You'll find that a good chunk of the time you're doing about 3 or 4 things over and over again between the different problem types. So seeing them all together hopefully kind of put some ideas together in your mind. If you have any additional questions, feel free to reach out to me either in person or via email. Otherwise, I will see you on test day. Bye!